Every year, earthquakes claim thousands of lives. But what actually happens inside the human body in those final moments? Not the destruction around you, but the biology within you. This is the science of dying in an earthquake. The instant the ground begins to shake, your brain sounds the alarm. The amygdala, the brain's threat detection center, fires in milliseconds. Before you've consciously registered what's happening, your adrenal glands have already flooded your bloodstream with adrenaline and cortisol. Your heart rate surges, blood pressure spikes, pupils dilate. Your body is preparing for fight or flight. But in a collapsing building, neither option may be available. As structures fail, the primary cause of death is blunt force trauma and crush injury. Falling debris, concrete, steel, timber, can strike with thousands of pounds of force. A blow to the head can cause traumatic brain injury within fractions of a second. The skull, though remarkably resilient, has its limits. For those who survive the initial collapse, a different danger emerges: crush syndrome. When heavy objects pin the body, particularly the limbs, muscle tissue begins to die from lack of oxygen. This releases a protein called myoglobin into the bloodstream. The kidneys, overwhelmed by this toxic flood, can fail within hours. Beneath the rubble, oxygen becomes the enemy of time. In a small, sealed space, carbon dioxide levels rise as oxygen depletes. Breathing becomes labored. The brain, which consumes 20% of the body's oxygen despite being only 2% of its mass, begins to suffer first. At around 90 seconds, without adequate oxygen, neurons start to fail. Cognition blurs. Confusion sets in. The world narrows to sensation, pressure, heat, the sound of your own heartbeat. Many survivors report a strange calm at this stage, a neurological response as the prefrontal cortex goes quiet and the brain conserves its remaining resources. If oxygen deprivation continues, the brain enters a state called hypoxic ischemia. One by one, regions of the brain go dark. First higher cognition, then motor control, then autonomic function. The heart, deprived of the electrical signals it needs, begins to falter. Cardiac rhythm becomes irregular, then it stops. Clinical death occurs, but the body does not give up immediately. For several minutes, cells continue their chemical processes. Consciousness, neuroscientists believe, may linger in some form. A final quiet storm of neural activity as the brain releases a surge of electrical energy. Some researchers call this the dying brainwave. It may be responsible for the vivid experiences some near-death survivors report. Then gradually it ends. The cells exhaust their last energy reserves. The electrical storm fades, and the body becomes still. Earthquakes remind us how fragile the boundary between life and death truly is, and how extraordinary the human body is in its final moments of resistance.